Let's go to page 207 and start with number 294. Okay, you have a point P is outside a circle. Okay, so let's get a circle. And you have a point P that is outside the circle. And it's 13 from the center. So that's 13. And a secant from P cut the circle at Q and R. So the external segment of PQ is 9 and QR is 7 from the radius of the circle. Okay, so what we're going to do is we're going to label this R, and going to label, so this is 13, so this would be a 13 minus R. Okay, so let's apply to the point formula. So from point to circle, that's 9, times point to circle, that's 16. You have to add this. We're equal to point to circle, that's 13 minus R, times point to circle, so that would be 13 plus R. Right, because it, from here to here is 13 plus R. Okay, so this will equal to 169 minus R squared. And let's go and move things around. So R squared equal to 169 minus 144. So this is, if you recognize this is a square of 12, this is square of 13, so this should be a 5. So 5, 12, 13. But if you don't see that, that's okay. So you got R squared equal to 25, so R equal to 5. Okay, let's go to 295. Okay, 295. The point ABC are on circle C. Okay, so let's get a circle. The tangent line at A, so tangent line is A. The tangent line at A and the secant BC intersect at P. Okay, so point ABC on the circle, so tangent A and the secant BC intersect at P. B lies between, so B lies between C and P. So B is between C and P. Okay. If BC equal to 20, PA equal to 10 square root of 3, and find PB. Okay, so you can use the point formula. So point to circle times point to circle, right? It's a tangent, so it's only one point, right? So you have to do it twice. We're equal to point to circle times point to circle, and then go and work it out. So 300 equal to x squared plus 20x, and then move this over and switch sides. So you got x squared plus 20x minus 300 equal to 0. Then go and do the master product factoring. So if you don't see the number right away, you just start with 1, negative 300, 2, negative 150, 3, negative 100, 4. So again, this will be twice. This is twice as that, so this will be half that. Okay, and then 5, negative 60, 6, negative 50, 7, 8, cannot 9, no 10, negative 30. And when you get over here, you can see that you have to switch the sign, so it will be 30, comma negative 10. Okay. Okay, so you can do just factoring, so it will be plus 30 minus 10. So x equal to negative 30 or x equal to 10. Now because we deal with the real object or the picture, so it cannot be a negative. Okay, so x equal to 10. Let's go to 96. Alright, so number 296, the picture is giving, so that's kind of nice. Okay, so you got A, E, G, C, F, D, E. Okay. So in the diagram, so EB bisects CD. So EB bisects CD, so these two are congruent. And C is the midpoint of AD. C is the midpoint of AD. Okay, so right away, okay, we can label this as Y, Y, 2Y. And the reason we use a Y because we reserve the X for what we're looking for. So find GB, so it means we're looking for that. That's X. If AB equal to 16, EF equal to 2, and FB equal to 3. Okay? Okay. Okay, well first we need to find, from this we can find Y. Okay? So you apply the inside force, so you're going to get the, so from here, okay, you're going to have the point to circle times point to circle will equal to point to circle times point to circle. Okay, so from here you can see that Y equal to square root of 6. So I'm put the numbers in here. Okay, so now we can go ahead and figure out the X. So you can from point to circle, that's 16 minus X. Right, because this is 16 and this is X, so this is 16 minus X. So point to circle times point to circle equal to point to circle times point to circle. So this will be total of 4 square root of 6. Okay, so that's going to work it out. So you got 256 minus 16x equal to 48. So plus 16x to move this to the other side and minus 48. Okay, so you got 208 is equal to 16x divided by 16 divided by 16. So x equal to 13. Okay, let's go to 297. Okay, so it says two tangents are drawn to a circle from the external point. Okay, let's go and call this A, call this B, and C. Okay, so two tangent lines are drawn to a circle from external point A. They touch the circle at point B and C, respectively. A third tangent intersects the segment AB at P. Okay, okay, so intersect AB at P. Oh, P over here, and AC at R. Okay, there we go. And let's go and call this Q. Okay, so, okay. And if AB equal to 20, find the perimeter of triangle. So you're looking for perimeter of the triangle APR. Okay, so you're looking for the perimeter of the APR. Now, one thing you have to realize that the common tangents are congruent. So AP is going to congruent to AC. Okay, and so okay, yeah, so 20 is out here. Okay. Now, what you need to realize is that the PB, so PB is equal to PQ. Okay. So if you fold this over to here, okay, and you have the RC is equal to RQ. So you fold this over, okay. So this part, when you fold it over, it becomes right over here. Okay. So you can fold it over. And this over here, when you fold it over, it becomes this part over here. Okay. And therefore, from here you can see the perimeter when you fold it. So this is 20 and this is 20. So when you fold it over, so the perimeter equal to 40. Okay, let's go to 298. Okay, a circle is inscribed in a triangle. Okay, so I'm going to draw the circle first. A circle is inscribed in a triangle. With a side, okay, a circle is inscribed in a triangle with a side length of 8, 13, 17. So 8, 13, and 17. Then the segment of the side length 8 made up by a point of tangency to be R and S, with R smaller than S. So this is R and this is S. Find the ratio of R to S. Okay, so from here, so again, common tangent. So if this is R, this would be R. This is S, this would be S. If this is R and this is 13, so this would be 13 minus R. This is S, so this would be 17 minus S. Okay, so now, so you basically just go around the triangle. Now, but these two are common tangents, right? So these two have to be equal. Okay, so you got 13 minus R equal to 17 minus S. So you move things around. So plus s, and you minus 13, So you got s minus r is equal to 4. Okay. But we also from here we can see that s plus r is equal to 8. Okay. So we got s plus r equal to 8. So we can go and solve. So this is from here. Okay. So you got 2s equal to 12. So s will equal to 6. And once we find s equal to 6, we can use either one of these to find r. So r equal to 2. So r to s will equal to 1/3, will be 2 to 6. Okay. Now, if you can also write in a fraction as 2 over 6 would be 1/3. So either way. Okay, let's go to 299. 210. Okay, so this figure is giving okay, you got circle. Okay, number 299. Okay, the center of the circle is O. AB is perpendicular to BC, right? Because again, because this is the tangent, and tangent is perpendicular to the radius to the point of tangency, right? And it says ADOE. So ADOE is a straight line. Now AP equal to AD. So AP. What's our P? So AP equal to AD. And AB has a length twice the radius, so AB is twice the radius. Okay. Show that, so you want to show that AP squared equal to PB times AB. Okay. Let's go and let this equal to x. Okay, so that's what you want to prove. Okay, so let AP let AP and AD equal to x. Then after that, we're going to apply the point formula. Okay, so point to circle, that's x. So well, let's do the letters first. So AD times AE equal to AB times AB, right? So point to circle times point to circle equal to point to circle twice because it's a tangent point. Okay, so AD is x. The AE is x plus 2r. Because again, because this is the diameter, right? Because it goes through the center, so this is the diameter. So diameter is 2r, so it would be x plus 2r. And AB would be what AB is giving, right? It is 2r. Okay, so after you multiply out, so you get x squared plus 2rx equal to 4r squared, and you move this over. So you got x squared equal to 4r squared minus 2rx. And then after that, go and factor the 2r to the back. You got 2r minus x times 2r. Right, you can factor the 2r to the back. And now we can see that you go back to match the picture. So what's x? Okay, well x is AP, right? Again from here, see, x is AP. The reason we choose x because it's easier to move things around and easier to see. Okay, so you got AP squared, right? Because x is AP, and 2r minus x is PB. Okay, because this is x, and this would be 2r minus x, right? Because this whole thing is 2r. Okay, so 2r minus x give you 2r minus x. So 2r minus x is the PB, and 2r is AB. Okay, see 2r that is giving is AB. Okay, and that's what we need to prove, and that's it. Okay. Okay, let's go to 300. Okay, 300 is to find the area of the inscribed circle in a triangle with side of lengths of 20, 21, 29. Okay, so you got 20, 21, and 29. Okay, so this one you actually is a right triangle, so you can check. Okay, so 20 squared plus 21 squared is equal to 29 squared. So first you go and check. So you got 400 plus 441. Again, we put a question mark because you don't know yet. You go to 841, and so you got 841 equal to 841. So check. Okay, so therefore this is a right triangle. So if it's a right triangle, then when you put that over here, this would be tangent. Okay, so this would be R, this would be R, and therefore this is a square R. Okay, and so this would be 20 minus R, it would be 21 minus R, and this would be 21 minus R by common tangent, and this would be 20 minus R. And then from here you can see that 21 minus R plus 20 minus R equal to 29. Right? So you can just start from here, you kind of go around the triangle. And then from here you're going to get 41 minus 2R equal to 29. So move plus 2R on both sides and minus 29. Okay, so you got 12 equal to 2R, so R equal to 6. Okay, then after that, now you can go and answer the question. Okay, you're looking for the area of the circle. So once you find R, you can find area of the circle. So area of the circle would be pi R squared. So area would be 36 pi. Okay, let's go to 301. Okay, so this picture is giving so I kind of extend the point. So this is the O, and this is the D. And this is the C, and this is the B, and this is the A. Okay, so I will extend from here, go up here. Okay, then let's go and put in the information. Okay, so if BC equal to DC equal to 3, so BC equal to 3, equal to DC equal to 3, OD equal to 2, so OD equal to 2, and AB equal to 6. Okay, so we don't know what this is over here, that's going to call it R. So from here to here is R, from here to here is R, so this would be R minus 2. Okay, from A to D, so AD is R minus 2. Okay, so we are looking for the radius of the circle. Okay. Okay, so we can apply the point to the circle formula. Okay, so you have AB to AB, so point to circle equal to point to circle, that BC, times point to this circle here, that's going to call it E. Okay. Okay, so you have the 6 times 6 equal to BC equal to 3 times BE. So divide by 3, so BE equal to 12. Okay. So BE equal to 12, but this is 3 and 3, so DE will equal to 6. Okay, so from here you can see that DE equal to 6. So once we find DE, now we can go and do the inside now. So before we do the outside, now we can do the inside. Okay, so you're going to have the point to circle. So we're going to repeat the same process. Okay. So we're going to have the DE point to circle to DC. Okay, point to circle equal to. So this point actually, let's go and call it F. So equal to DF times D. Okay, let's call it G. Okay, so you can point to circle times point to circle equal to point to circle times point to circle. Okay, so DE equal to 6, DC equal to 3, DF is R minus 2, DG is R plus 2. Okay, so 18 will equal to R squared minus 4. So R squared equal to 22. So R equal to square root of 22. Okay, let's go to 302. You want to prove that if a quadrilateral ABCD is ortho-diagonal, okay, and it's circumscribed around a circle. Okay, if a quadrilateral is also diagonal and it around a circle, then it must be a kite. Okay. Okay, so let's go and call this A, B, C, D. So again, if it's also the diagonals are also diagonal, so it means that they're perpendicular to each other, and it's circumscribed around a circle. So therefore, it must be a kite. Okay, and since if it's a kite, it's symmetrical. Okay, so in this case, you got AD equal to AB. Okay, and you have CD. Okay, put CD down here. So CD equal to BC. Okay, again, it's a kite. It has to be a kite. And therefore, when you multiply, you get A. Okay, that's going to switch. AB, and this is AD. There you go. So when we multiply, we get AB times CD equal to BC times AD. Okay, and that's it. Okay. So the part you have to prove that you can prove about the kite, and it is a kite. Okay, and you can do the you can go and just prove. Okay, so like this one over here. So these are congruent. These are right angles that have to be congruent, and the tangent point, this is congruent to this, right? Okay, and also and since this is congruent and you cut through over here, you actually can do this first, okay, and you can prove that triangles are congruent, and then from here do the same thing. And after you can use the same method, you can prove that since they're congruent, and therefore it's going to be a kite. Okay, so we kind of did this from before already. Okay, but anyway, so it's a kite. So once you realize it's a kite, and then it's just symmetrical, and it would be just congruent to this side. This side is going to be congruent to this side, and therefore you just multiply, and that's it.